Kimba. Welcome everyone to our 10th Psychedelic Shine. This is a very special shine in that it's maybe the last one we do in our Shine home here with Shine Restaurant moving, so it's a very special day. We looked at other places, but it was just too special to not do it here this last time. It's also our 10th one, so it represents the completion. We're excited to host you for this special event with Dr. Gallimore. Thank you, Kimba, for a beautiful opening. Kimba is the director at Radiance Health, a medical health and wellness center, and she is a master sound healer. And her work can be found on our website, gaearth.com, Gaearth.com. She's a true spiritual sister, and we're really grateful to have her open these important events and ceremony. That's important to us. My name is Daniel McQueen, and I'm the Executive Director of Medicinal Mindfulness. And we have a lot going on, so please sign up for our newsletter in the back, learn more about our services. You can check out our website, medicinalmindfulness.org. But before I introduce Dr. Gallimore, I would like to introduce the day and thank the team that is filming this event. We have Nathan Bloodsworth of Syndicate Studios over here in the corner, Ben Stewart, a producer at Gaia TV. I don't know where Ben is. And Scott Rowland and ALOC Media, and Joe Moore of the podcast Psychedelics today is helping us live stream the event. He's right over here. So we're hopeful that we've got an international audience right now, if everything works as we have planned. We'll also have the lounge area reserved for during the break and after the event before breathwork. And Ben will be conducting some interviews. If anybody has anything they'd like to share, it'll be on a new series on Gaia TV on psychedelics that's coming out in the fall. So we'd really want to hear feedback from the community and get the voice of the community in these documentaries. Kimba, Psychedelics Today, the Psychedelic Club of Denver, and Nabumbu, our band, is our sponsors today, so please check them out on social media. And we're really grateful for the support that they gave us in getting you all here and advertising this event. And I'd like to thank the volunteers. Everybody wearing a blue shirt are volunteers, so if you need anything, just let us know. Thank you for hosting us, Shine. It's been really great, and so please support Shine by getting some drinks and food, either at the break or after this. Thank you, Allison, my wife, for going on this crazy wild ride with me. It's been great. So our format's a little different today. We have our keynote, Dr. Gallimore speaking first. It'll be in two parts with a little break in the middle, and that's more to just let a stretch your legs break. After that, Nabumbu is going to play for 20-30 minutes with a music set, because we really like to incorporate music into our events. And then it's also an opportunity to hang out, get to know each other, chat, meet each other. Get interviewed in the lounge over here. And after the music, I'll be given a short presentation on a path I believe that can take us to actually doing extended state DMT research. So I really would like you to stay around for that if you can. We should be done here by 5:30 with this part of it. We got started a little late, and these always run a little over. And then we're going to have a dinner break. And then 6:30 to 9:30 is our community breath work here. So if you haven't signed up for that, there may be one or two tickets left. I don't know. We can check the table back here. But that's an opportunity to breathe through any blocks, to any personal blocks, collective blocks, for us to step into doing more work like this in the world. At our last Psychedelic Shine featuring Dennis McKenna at the Boulder Theater, I gave a presentation on the potential radical new psychedelic research proposal on extended state DMT. This was designed by Dr. Andrew Gallimore and Dr. Rick Strassman. Once we got the presentation online, I forwarded the link to Dr. Gallimore to see if he thought I was crazy or not. And apparently he is just as crazy as I am. When I sent this poster, with the event's poster description to Dr. Strassman, the talking to aliens theme and all, he suggested that maybe I run it by Dr. Gallimore first, just in case we should, minimize that language. And I had to tell Dr. Strassman that this was all Dr. Gallimore's idea. This is the same Dr. Strassman that wrote DMT, Spirit Molecule, and DMT and the Soul of Prophecy and all of that. And it was synchronistic that Dr. Gallimore is in Boulder this weekend. He said yes to letting us put on a shine so he could present his ideas. Obviously, this gave us an opportunity to take a further step into manifesting extended state DMT research. So here we are. And today is what came out of that expedition, so we're really grateful that you're all here. We have people who have flown in for this from other parts of the country, and again, might be listening internationally, which is great. I think Dr. Gallimore can explain what he does a bit better than I can, but he is a computational neurobiologist, pharmacologist, and chemist currently based at the Okinawa Institute of Science and Technology, where he uses computational modeling to study brain function. He has been interested in the neural basis of psychedelic drug action for many years and is the author of a number of articles and research papers on DMT and the psychedelic state. He recently collaborated with DMT pioneer Dr. Rick Strassman, author of DMT, the Spirit Molecule, to develop a pharmacokinetic model of DMT as the basis of a target-controlled intravenous infusion protocol for extended journeys in DMT space. Andrew will give a multimedia presentation on the use of this powerful psychedelic drug as a tool for exploring worlds beyond this reality and for communicating with otherworldly intelligent beings. He will tell us all about his extended state DMT proposal. His website is buildingalienworlds.com. Let's give a big Boulder welcome to Dr. Andrew Gallimore.
Good evening, everyone. Oh, good evening. Good afternoon, everybody. I'm still a bit jet lagged, so it's evening for me. Thank you very much. It's really wonderful to be involved. My first time in Colorado. First of all, can everybody see me? More importantly, can everybody see the slide show? Do these lights?
Yeah, we need them for the cameras.
Okay, as long as everybody can see. Everybody understand my accent? So, anybody here from the UK? Nobody? Okay. Any Irish? Half the room. Yeah. Okay, so thank you, Daniel, by the way, for inviting me. It's really nice to be here. My first time in Boulder. So if you're interested in what I'm going to talk about today, then please do go to my website, buildingalienworlds.com. So what I'm going to do is I'm going to start with kind of a brief 5-minute anecdote to kind of as a contextual anchor, kind of my experience so far in Boulder. But then I will segue pretty seamlessly into the main talk on psychedelics. So if you listen carefully, you might hear the gears change on that. So I arrived in Boulder on Friday night. I was pretty tired, so I went straight to bed, and I didn't really get to see the city until Saturday morning. So I took a walk. Whenever I arrive in a new city, the first thing I do normally is buy razors. I'm a prolific consumer of razors, and you can tell a lot about a city, I find, by the availability of high-quality razors. And say Boulder is exemplary in that regard. So I walked. It was pretty early in the morning. I woke up like 6 a.m. because of the jet lag. And I took a stroll along 28th just to the Safeway. And I was picking my razors, and I was stood in the checkout, I guess you call it a cash register, and there was a guy in front of me, and he looked a bit bedraggled, I guess. He looked like maybe he had a tough night, and he only had 2 items, and I noticed them specifically. He had a single apple and a pen. Right? It's just a simple, nothing special. Just one of those plastic kind of big pens, right? And a green apple, right? Single green apple. I'm not sure if that is relevant, but I'm aiming for kind of full disclosure. I want to give you all the information that I have. So I noticed it specifically because I wondered, did he get up this early specifically to get those 2 items, or did he kind of browse the store and narrow it down to that selection? But anyway, he decided on this pen, this green apple, and he seemed to be struggling with paying for it. Maybe didn't have much money, but anyway, he paid for this pen and this green apple, and I kind of forgot about it. And I thought he'd left the store, but he hadn't. He'd just kind of gone to the side of me. As I was paying, the lady was cashing through my items, my razors and such. This lovely little old senior lady came shuffling over, and she shouted, and I thought she shouted to me. She said, "Sir, why are you doing that, sir?" And I thought, what? But she was actually talking to the guy over my shoulder. And then she said, "Sir, why are you pushing that pen through the apple?" So the guy didn't say anything. He continued. I mean, obviously, he didn't leave the store. So, such was the urgency of this procedure. But then he kind of slunk away, and the lady said, "Did you see that?" And I said, "I've just arrived in town. I'm not familiar with kind of local customs." And then I said, "Is everybody going to be like this?" And she said, No. He's exceptional. But anyway, he slunk away, and he never did explain to us why he was putting the pen through the apple. So if anyone has any idea of why he was doing that, please see me afterwards. But interestingly, when I saw this kind of bedraggled figure with the apple, it reminded me of the story of Adam and Eve in the Bible. Because, of course, in the story of Adam and Eve in Genesis, the apple is the forbidden fruit. And in a way, psychedelic drugs are kind of the forbidden fruit of our age, aren't they? And that, ladies and gentlemen, is how you segue between an anecdote and the main topic of the discussion. Okay, so DMT. Anybody heard of DMT? Okay. So DMT, this remarkable, the simplest of the classic psychedelic, so-called classic psychedelics. So we're talking about psilocybin, we're talking about LSD, we're talking about mescaline. Dimethyltryptamine, however, the simplest of these. The most widely occurring in nature, and yet also the most astonishing. So DMT, rather simple structure. You have this indole decorated with this ethyl group and then this dimethylamine group. Don't worry about the details of that. But DMT is an exceptionally simple molecule. But what is not simple is what it does to you. And kind of what I want to do today is, rather than just give you a talk about kind of my work and sort of research and that kind of stuff, I'd rather you go away not having just learned something, but kind of feeling like you have a deeper understanding of psychedelics and deeper understanding of the nature of reality and a deeper understanding of the nature of yourself even. So I'm setting the bar pretty high, and I might fall a little short, but I will do my best. I'm told you're a smart crowd. So I'm going on the assumption that you're all pretty smart. So I won't spend too much time talking about what we call the phenomenology of DMT, the effects of DMT. I imagine most of you in this room are familiar with that. So DMT, we know, has this rapid, extremely intense onset. Leary described as like being fired out of the barrel of an atomic cannon. But it's also very, very brief. 5-10 minutes with if you vaporize it, which is by far the most common mode of administration. But the most interesting part of DMT, in terms of its effects, is this complete replacement of what we call consensus reality, this complete 100% reality switch, where the normal world that we're all used to and familiar with disappears in an instant and is replaced by a world altogether stranger. Often described as having this bizarre, hyper-technological ambience. But it's not so much where you go with when you smoke DMT, it's who you meet there. And many people, when they smoke DMT, describe experiencing meetings with extremely intelligent beings, not of this world, not of this universe. So, when you describe the effects of DMT to people, you can normally place people kind of into two camps. You have the believers, if you like, and they will say, well, what DMT does is it allows you to access an alternate universe. It takes you, transports you to a parallel universe, an alternate alien reality. On the other hand, you have the non-believers, the skeptics, yes? The rationalists, and they will say, no. DMT is merely eliciting a highly complex hallucinations. But we don't really believe that, do we? And generally, it's people that have smoked DMT that fall into the first category, because the nature, the reality of the DMT space is undeniable. So it shouldn't surprise you, or maybe it will surprise you, that I'm going to be coming from the first position mainly here. I'm not going to spend a lot of time discussing the pros and cons of the alternate reality versus hallucination argument. I'm going to assume that most of you here are pretty open-minded. So the first part of my talk, I'm going to talk for about an hour. First of all, 50 minutes to an hour, depending how long it takes me, obviously. And talk about the structure of reality and what DMT actually does. When people say DMT transports you to an alternate universe, what do they actually mean by that? You know, you see, if somebody smokes DMT, they remain there in front of you. They don't physically go anywhere. So you might say, well, they go somewhere in their mind. You know, and what does that mean? Are they actually going somewhere? These are often questions that are very important, but not really dealt with. So I aim today to go deep. To go deep and look from the ground up, to start with the structure of reality and kind of change the way you think about reality and the structure of the world around you. And that will then enable me later on to show you how DMT and psychedelics in general, actually, but DMT specifically, can change your reality. Then in the second half, we'll have a short break for about 10 minutes, as Daniel said, just a comfort break. And then I will go into talking about some of the more pragmatic, practical stuff with this DMT extended work. So the first half is going to be fairly intense, so you will need to concentrate, I'm afraid. But I will be supplementing my talk with lots of visual imagery, so please take note of the visuals. Okay, so let's start right at the bottom. So, does anybody know what this is? Yes! Wow. This is a cellular automaton. It's a special cellular automaton called the Game of Life. Now, what is a cellular automaton? Well, this was a type of computer program invented by a mathematician called John Conway back in the 70s. And as you can see, it has a basic structure. It has these grid of squares called cells in cellular automaton language. And each of these squares can be in one of two states. It can either be white, often referred to as being dead, or it can be colored, black generally, referred to as being alive. And you can see lots of these interesting patterns forming across here. And you may be asking, what's this got to do with psychedelics? You know, where are the drugs? You might be thinking, not for the first time, I imagine, in your life. The drugs are coming, yeah? We just have to get there. Okay, so the cellular automaton, I'll talk you through how this works. And it seems a little bit abstract and a bit strange to be talking about this, but it will all make sense, hopefully. So the cellular automaton is this grid. And as I said, each of the cells of this grid can be either in one of two states, alive or dead. In this case, black is dead, blue is alive. And at each point in time, every cell on this infinite grid will either be in one of these two states. And the way that a cellular automaton program runs is by updating the states of all the cells in parallel at exactly the same time. Everything is happening all together everywhere at once on a cellular automaton, as Alan Watts once said. So the Game of Life has four basic rules. So we look at a cell here, which I've highlighted, and then we look at the cells, what's known as the cell's neighborhood. And that's simply, as you'd expect, the cells that are surrounding the central cell. And what the central cell does is, so in this central cell here, it's in the alive state. If a central cell is alive and it has less than two living neighbors, so less than two of these are alive, in this case only one, it will die of loneliness, right? So it becomes black. If, on the other hand, it's alive and more than three of its neighbors are alive, it dies of overcrowding, like this. If, however, precisely three of its neighbors are alive, so we've got exactly three neighbors here are alive, then it remains alive. And if a cell is already dead, then it will remain dead unless exactly three of its neighbors, doesn't matter which neighbors, but exactly 3 neighbors are alive, then it will become alive. And these are the 4 rules that govern the so-called game of life. So every single step of time in this computer program, every single cell will look at its neighbors and basically decide what's my next state. So in a sense, what's happening is the central cell is receiving information from its neighbors. That's a really important concept, this idea of receiving information from its neighbors and deciding what it will happen. Now, amazingly, when you run this program, it exhibits really quite startling behavior. So this is, you can't see, this is because the cells are so small, but this is running entirely from these 4 simple rules. These creatures that appear to be moving are not moving, it's just the cell states are changing and give the appearance of these objects moving. This is even more interesting. We can see these very small objects here, which moving in, and then they self-organize. This is not programmed, these self-organize, and they form these structures, what are known as spaceships, which once they are fully formed, and only once they are fully formed, they then drift away like this. And this is, the game of life is actually actively studied. There are forums on the internet where you can go, where people are discovering new structures in this program. And it's hard to believe, really, when you look at it, that this all arises from these 4 simple rules. Simple rules often gives rise to great complexity. So if you don't believe me that this is actually just cell states updating, we can look a little bit closer up. So this is something called a glider gun, or a pair of glider guns, because they emit, as they move back and forth, they emit these little creatures here, each made of 5 cells, called gliders. So here you can see, certainly, this is simply cells updating. So let's have a look a little bit more closely at what's actually going on here. So this is a glider. This is the 4 states, including the return to the original state, of a glider. In the bottom right here, we can see it moving. We can see it's moving diagonally to the right, the grid moving with it, so it stays on the screen there. And what the glider is doing is it's moving between these 4 states, and then it returns to its original state, but it's moved. And so it recycles through this. Now, if you actually apply the rules of John Conway's Game of Life to this, as I've described, actually you will see that this is exactly what happens. This isn't made up. This is how it works. So this behavior like this. So if I was to ask you the question now, what is this glider? What is it? Is it an object? You might say, well, no, it's not an object, Andrew, because the cells are actually changing. So the cells that make up the glider here are different to the cells that make up the glider here. So it can't be an object, because an object has to retain its components. So then you would say, well, what could we call it then? We could call it a process, I guess. We could say the glider is a process. But actually, the best way to describe this glider is as a pattern of information. And we're going to be talking about patterns of information a lot today, because understanding information and patterns of information is essential to understanding psychedelics, and certainly for understanding DMT. So I guess the first thing I should do is ask the question, what is information? And everyone has an intuitive understanding of what information is. And if I asked everyone in this room what information was, I'd probably get 7, 8, 9, perhaps more different answers to that question. So I'm going to give a very precise definition of information. And it will seem a bit abstract at first, so don't worry about that. So information is generated when a system selects between a finite number of distinct states. Now that sounds very strange, but has anyone ever flipped a coin? Ridiculous question, of course, but here I have a 25-cent coin, yeah? You'd have thought there'd be a shorter name for it, but anyway, so this 25-cent coin, I'm going to flip it, call it? Tails, okay. Tails, okay. So if I asked you now, so you don't know what it is. I know whether it's heads or tails, but I could ask the question, how much information would you gain by me telling you whether it's heads or tails? Anyone know the answer to that question? Well, I'll tell you. It's actually tails. Well done. You can buy me a beer. But the answer is that whenever you have a choice between two states, in this case the coin can only exist in two states. We ignore the landing on its sides. Forget about that one. Yeah, either heads or tails. So it's a two-state system. And when you select between two states, you gain a very important amount of information known as the bit. And we're all familiar with bits, or we should be, from computers, of course. But let's have a slightly more complicated example. So it doesn't have to be coins, of course. It can be anything that can exist in two states. And it's actually the bit is regarded as perhaps the most fundamental unit of information. And you can build highly complex information just from bits. And of course, we all know this. We know that the computer that I'm running now is using, at its core, it's using bits. It's using two states, sequences of bits to encode extremely complex information. So let's look at another example to really cement this idea into your mind. So let's imagine a more complex system. Let's say we've got a 64-state system, which I will represent as a 64-square grid, because that's a pretty straightforward, simple visual way to understand that. And so by selecting one of these grid, we basically put this system into one of the 64 states. And the question now is, if you didn't know, let's say we chose this square here. So this is one out of a possible 64 states. How much information would you gain by learning the state of the system? One out of 64. So let's try and work this out. So for example, if I had chosen the square and not told you, and you wanted to find out, and you could ask me questions, you could just say, okay, where is it? Which state is it in? But that wouldn't particularly instructive. But how about we use this method? So what we're going to do is we're going to split the system into halves, and we're going to use a series of yes-no questions. So the top and left here, this will be complicated what I mean by this. This is to do with the algorithm we're going to use to get the answer. So we split it into two halves and we ask a simple question, is it in the left half? The answer is, of course, yes. Good. So we can get rid of the right half. So then we split it in halves again and we say, is it in the top half? Yes. Great. So we can forget about that half. We split it in half again. Is it in the left half? No. Great, so we can get rid of the left half, split it in half again. Is it in the top half? No, we can get rid of that. Split it in half again. You get the idea now. Is it in the left? Yes, it is. Split it in half again. Is it in the top? Yes, that's the one, and we found it. So this is actually the most efficient way of finding an object on a uniform grid. And you'll notice that as I was bring this down, doing this, I was placing digits on the bottom of the screen. These were basically the answers to the yes-no questions. So 1 for yes, 0 for no. So yes, yes, no, no, yes, yes. This is 6 bits of information. So now you know that a 64-state system encodes 6 bits of information. Or in other words, you can represent this rather complex system. Imagine a 64-sided die. Quite complex, right? But you can represent it as a sequence of bits. Does that make sense? I haven't lost anyone yet. Great. So now we can look at this with fresh eyes. So now we understand that information is generated when a system is selecting between a certain number of well-defined discrete states. So in the game of life, this cellular automaton, we've got just two states. And so this is clearly a pattern of information. The glider, or this, is basically selecting, the cells are selecting states as they go along. And so this is clearly just a pattern of information. So, whilst the glider is a very simple pattern of information, as we've seen before, the game of life can often give rise to very complex patterns of information. And often what happens in the game of life is you will see very simple patterns of information, I call them critters, just for simplicity, will often join together to form larger, more complex patterns of information. So here we've got these little beasties, these little critters, which are joined together to form more complex structures. So sometimes we refer to these simplest structures that are just made of a few cells as first-order structures. and then they form these higher order structures, second order, and these can join third order. And all the time, as you're getting more and more of these structures joining together, you get this hierarchy of complexity, and it gets more and more complex. And sometimes it becomes so complex that you lose sight of the fact that you're dealing with these simple patterns of information, because it's a highly complex pattern of information, but this is running entirely using the 4 simple rules of Conway's game of life. Pretty amazing stuff. Okay, so let's look in a little bit more detail then at these patterns of information. So let's revisit this glider gun in close-up. So then let's zoom out, and we can see we've got actually 2 glider guns, and they are emitting these gliders in opposite directions. And when the gliders meet, they annihilate each other. What's actually happening is that you've got patterns of information coming in both directions, and when 2 patterns of information meet each other, they modify each other, they affect each other. So information is processed. So one pattern of information can interact with another pattern of information and change that pattern of information. So this, I'm not suggesting, of course, that the game of life is really living at all, but it is a really nice way of viewing the world. And this view of the world, actually, the idea that ultimately everything can be explained, no matter how complex it is, in terms of information processing, and I'll give some more examples kind of from the familiar world in a second, can be probably traced back primarily to an eminent theoretical physicist called John Wheeler, who said every particle, every field of force, even the space-time continuum itself, derives its function, its meaning, its very existence entirely from the apparatus elicited answers to yes or no questions, binary choices, bits. Everything is information processing at its core, at the ground of reality. So this way of looking at reality matured into a branch of physics still relatively new and still relatively niche, called digital physics, digital philosophy. And Ed Fredkin, the computer scientist, apologies for all the words on here, but he says something quite neat here. He says, if we could look into a tiny region of space with a magic microscope so that we could see what was there at the bottom of the scale of length, imagine the grids of cells in Conway's game of life, we would find something like a seething bed of random appearing activity. Space would be divided into cells, and at each instance of time, each cell would be in one of a few states. A snapshot would reveal patterns of 2 or 3 or 4 or some other small integer kinds of distinguishable states. In the Conway's game of life, of course, it was simple 2 states. It would either be pluses and minuses, blacks and whites, 7 shades of grey, ups and downs, or whatever. The point is that it would be equivalent to digits. So what Ed Fredkin is suggesting here is that the ground of reality, we have a discrete, perhaps a digital system of simple rules interacting to create increasing layers of complexity. Now, anyone who's studied biology will be familiar with this idea of hierarchies of complexity. So right at the base of reality, we have the fundamental, the grid, if you want to call it that. It doesn't necessarily have to be a cubic grid, or the actual structure is unclear, but it would be a discrete grid-like structure, or perhaps a network-like structure that operated according to a few very, very simple rules, basically information processing at the ground. Then these, perhaps through several layers of complexity that we don't yet understand, you get the emergence of fundamental particles, the electrons, the quarks, the Higgs, yeah? But these, of course, are simply patterns of information in the same way that these lower-order structures are patterns of information. And the fundamental particles then form patterns of fundamental particles that we know as atoms. Atoms form patterns of atoms we call molecules, and under certain circumstances, large numbers of molecules form extremely complex patterns that we call cells, and the cells form tissues, tissues form organs, and right at the pinnacle, right at the apex, possibly not, is the organism, because we sit at the apex. And in the same way that in John Conway's Game of Life, when the structures you see become extremely complex, you lose sight of the grid. And indeed, whilst the ground of reality is pure information processing, we lose sight of that fact because it's way, way down, deeper, 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 and down. So from the base of reality, we get increasing complexity all the way to brains, conscious creatures like ourselves. So, to put it succinctly, everything is a manifestation of the complexification of information. So, let me give you another quick example from the real world. This is a network inside a neuron in the brain. Don't worry about what these are at all. Well, they're just molecules. We know that molecules, of course, are patterns of atoms all the way down. So molecules are simply patterns of information, and these patterns of information interact with each other through which complex functions emerge. This is the network of molecules inside a complete cell. Again, don't worry about the details, they're not important, but you can see it is inordinately complex. And of course, a cell is a complex beast, and it requires this complexity in order to be living. But actually, when you look at it deeply, you can see it's just a very complex network of molecules that are interacting. It's a complex network of patterns of information that are interacting with each other, in the same way that the gliders, when they met each other, interacted, except, of course, in the gliders' case, they simply annihilated each other, but often with highly complex patterns of information, you get much more complex behavior. So again, to put it simply, where there is information, there is life. And this applies not only to this world, but to any other world. So let's bring this a little bit closer then to psychedelics. So let me give you another illustrative example, again from the Game of Life. So we've got quite a complex structure here in the center. Imagine it's more complex than it is actually there. This is just for illustration. And you have 4 simple moving structures. You can see a couple of gliders moving towards it. Now, if this is sufficiently complex, when this glider interacts, reaches this structure and interacts with it, basically this complex structure is receiving information about what's going on up here. It's receiving a pattern of information which, if it's complex enough, it might be able to actually interpret in some way. And it might be able to say something like, oh, there's a glider gun over there. So in a way, this structure is exhibiting a simple form of perception. So we all know what perception is. We're all familiar with the idea of light, photons hitting your retina, these being converted into information in the brain, or patterns of sound waves entering your ears. But of course, we now know, with our new updated 21st century view of reality, that light itself, these photons, are simply patterns of information. So really, your perception is not so different to this. The patterns of information in the form of light photons, for example, are entering this complex pattern of information, which is your brain. And your brain is perhaps certainly the most complex, or arguably the most complex pattern of information in this universe that we're aware of. Probably not, though. Certainly not the most complex pattern of information in the kind of worlds that people often visit the height of a DMT trip. But your brain, all the same, despite again being at the apex of this hierarchy of complexity, is itself a pattern of information. And what your brain really is not only a pattern of information, but an information generator. Your brain generates information. And not only does it generate information, but it also receives information. This is perception, right? This is receiving the patterns of information from the environment, receiving light, sound, warmth, touch, all these kind of things. And what's interesting about brains, of course, is that they are, or they seem to be conscious. And that's I'm not going to go too deeply into consciousness, simply because it's such a thorny and difficult issue to grasp. But I'm not ignoring it. I am ignoring it deliberately. I'm not kind of neglecting it. We'll talk about it a little bit. Perhaps afterwards, if someone wants to talk about consciousness, they can do so. I have a few ideas, but I simply don't have the time here. So your brain is a generator of information. Remember, whenever the cell states of these structures are updating, they're generating information. So your brain is a very complex generator of information. Indeed, most of the information is actually generated much higher level in the complexity hierarchy at the level of neurons, and we'll talk about those shortly. But what's special about the brain is that this information manifests as your world. Your world is built from the information generated by your brain. It's a really important idea. The information generated by your brain feels like your world when viewed from the inside. We're viewing patterns of information on this screen here, but when you look around your world, you will see that it is extremely informationally rich. There is a myriad of forms, of textures, of distance relationships, of colors, of sounds, of smells, all of these things. These are all information. They're all information generated by your brain. And this applies under all circumstances, whether you're in the normal kind of waking world state, whether you are dreaming, or whether you are at the peak of a intense breakthrough DMT trip. The world that you experience is always information generated by your brain, but viewed from a subjective perspective. Max Tegmark used this kind of wonderfully. Max Tegmark is a theoretical physicist that's had some ideas about consciousness. A wonderfully kind of vague and yet pithy statement. We said that I have long contended that consciousness is the way information feels when being processed in certain complex ways. So there are a number of scientists that are looking at what is it about the complexity of the information generated by a brain that gives it a subjective viewpoint. And that's something we're not going to deal with. But your brain is always generating information, and when you are conscious, that information is always your world. So that's the kind of the important point here. But this isn't just any old information, is it? So for some reason, the information generated by your brain has something to do with what's going on outside. It's useful information. If you're out hiking in the Rocky Mountains, right? Yeah, contextual. Yeah? And you see a bear, for example, how you respond to that, that bear is in your head. People often distinguish between the real and the non-real by saying, oh, it's all in your head. Yeah? But actually, it's always all in your head. Always. So the perception, the experience of the bear is indeed information generated by your brain. But it has something to do with what's going on out there. And the way that you respond to that information may determine whether your information is terminated or not. So what the brain is doing is, although your world is built from this information generated by your brain, it's also receiving information from outside of the brain, if you like. I'm hesitant to use these ideas about the external world or the real world or the environment, because I think that I can very, very quickly trip myself up. But if you imagine one of these structures in Conway's Game of Life, there's everything that's outside the grid, if you like. So everything that's outside this brain we will call the external world, the environment, or whatever you want to call it. And the brain is receiving this all the time, so it's receiving information, but it needs to learn how to make sense of that information. So to kind of get you to understand how this works, why the information generated by your brain is so useful and enables you to kind of navigate this reality, we'll separate the information into two. So we'll split it. We'll talk about the information generated entirely by the brain, which is your world, always. And then we'll talk about the information being generated by everything that's going on outside of your brain. Then we'll simplify it even further by separating this information as being all your brain information, all the information generated by your brain is within this circle, and all the information generated in the external world is this circle. And your brain is a product of evolution like everything else living. And as your brain evolves, it is constantly receiving information from the environment. And eventually, the brain starts to produce information that tells you something about the environment. Let me explain what I mean by that. As you can see here, as we go, progress of neural evolution over millions of years, these circles begin to overlap, and then they overlap even more. And they overlap, and this overlapping region, anyone do Venn diagrams at school? Right? Yeah, you said, oh, I'm never going to use them. Yeah, here we go. So mutual information. So mutual information is the information we know about one thing by knowing something about the other. So for example, if I showed you a photograph of an identical twin, by looking at the photo of this identical twin, you automatically know something about the other identical twin that you've never seen. You know perhaps the shape of her nose, the colour of her eyes, perhaps the shape of her face. Even better, if I gave you the DNA sequence, the genetic code of this single identical twin, you automatically know the genetic code of the other identical twin without having to ever take her DNA, because they share what's called mutual information. Information that's shared by two different things. So what this is saying is that as the brain evolves, this complex information generator evolves, it starts producing information that actually tells you something about the environment. And that's really important, that a brain can do that. Otherwise, you're living in a world that might be very beautiful, but it's not an adaptive world, it's not a functional world, it's not a useful world. And evolution would strike that down. So, let's move away from these grids for a little bit and actually start to think about the brain itself. Try to understand how this works. I've spoken a lot about the brain as this information generator, that this information is your world. So let's think now a little bit more deeply about how does the brain generate information. So this is a slightly more realistic vision of the brain. We have all this stuff inside. This is kind of a slice. This is a coronal slice, I think. Anyway, and you've got these two halves of the brain, then you've got this outer layer of the brain, which is the cortex. Your cerebral cortex is this very thin, it's only a few millimeters thick, flat structure like a sheet, but it's actually quite large, maybe about this size, but it's tightly folded up so it can fit inside your tiny skull. And all of the world building, information generation, well, not all of it, but much of it is generated by this outer layer, the cortex. And the cortex of your brain is built from a number of different types of cells, many different types of cells, in fact, but mainly the most important one, which anyone who's studied any kind of biology up to kind of high school level will at least be vaguely familiar with, and that is the neuron. Wonderful. Thank you. So the neuron is the information processing, information generating unit of your brain, the smallest unit. Again, this idea of information. And the neuron, don't worry about details. Not going to be too many technical terms in this talk. I'll try and avoid it. So the dendrites feed into the cell body. The dendrites receive information from other neurons. The cell body receives this information and basically processes this information in a very basic way. And then it sends the processed information along this single structure called the axon, which then, that information can then be passed to other neurons. That's all you need to know. Now, all of these neurons in your brain are connected together to form very, very, very complex networks. But importantly, in the cortex, about 120 of these neurons form this complex network called a cortical column. And a cortical column, we actually see it a bit better here. This is actually a reconstruction of a microscope image, very, very high resolution microscopy. You can see all these neurons here, and they form these kind of cylinders. And here I've tried to represent it. These cylinders, you can see from the top here, and there are a number of layers in these cylinders. And these columns are the computational units of information generation in the brain. So a single neuron can only generate very, very simple information. But when they join to form these columns, they generate much more complex information. So if you were to look at your cortex from like a bird's eye view, you would see this kind of structure. All of these columns, all of these cylinders stacked sideways. to form this kind of pattern. Now, these cortical columns can either be active or they can be inactive. That's a massive oversimplification. It's not as simple as that at all. But let's just keep it simple and imagine that cortical columns can either be active or inactive. So we've got active columns here in yellow, inactive columns in grey, and of course this is a pattern of activation. It's a pattern of information. So this is a pattern of information generated by the cortical columns. And in your brain you have perhaps 2 to 400 million of these cortical columns all packed together like this. So it's the activation of specific cortical columns that give this pattern of information. And believe it or not, it's this pattern of information generated by these cortical columns that is your world, but viewed from the subjective perspective. You will also notice that these columns are not, they seem to be connected, but not kind of uniformly or randomly. They're connected in a very specific way. And this connectivity is really, really important. It allows columns to speak to each other. It also means that the types of patterns of information, the types of patterns of activation of these cortical columns can be kind of sculpted by the patterns of connectivity. So, for example, if this yellow one in the center here is activated, it means it's more likely to activate the columns to which it's connected. Whereas a cortical column that's not connected to hardly any other cortical columns is much less likely to receive information that causes it to be activated. So what the brain does, as we'll see, during kind of neuroevolution, is it tweaks and changes and modifies these patterns of connectivity, which modifies the patterns of information. So let's make this a little bit more concrete. So let's imagine you want to build a very simple world using a brain. Perhaps this cute little face. A simple world, just has this face, and he's moving kind of left to right in your field of vision. So let's think then how we might generate the information to build this very simple world. Well, we need to think about what kind of information do we need to encode by the brain. Well, we need to encode the shape, we need to encode these circles, we need to encode perhaps the colors of the eyes and the skin, the texture, we need to encode the movement. All of these things need to be encoded, and they're all encoded by information generated by these patterns of cortical columns. So let's try and make this even clearer, hopefully. So this is just 16 cortical columns. When I'm doing kind of explanations of how this works, I normally use this 4x4 column grid to kind of illustrate my points. But of course, in reality, we're talking about millions and millions of columns. So in the brain, there are specific regions, specific sets of columns that are given the role of generating motion information. There are regions that are given the role of generating color information, regions for texture information, regions for form broadly. So the outlines of objects, straight lines, curves, the overall shape of objects. And so we can see here that we've activated specific columns in the specific regions that generate a pattern of activation. And that pattern of activation is that, going back, is that experienced from the subjective perspective. So this alien face is represented by the information generated by this pattern of information generated by this pattern of cortical column activation. Anyone completely lost yet? So we're getting closer and closer now to the drugs. Okay. You'll see them when they arrive. So, so one thing that I mentioned when I introduced these columns is this idea of the importance of connectivity. And this connectivity is extremely important to appreciate because it's the connectivity, as I said, that determines the patterns of information that the brain naturally will adopt. We call the information, by the way, generated by the brain, that is your world, we call it the intrinsic activity of the brain, the internal activity. But that shouldn't be too important that you remember that word. Okay, so connectivity determines intrinsic information. Connectivity determines the patterns of information generated by the brain. So now we can start to think about, before I showed you that image of neuroevolution, the brain kind of learning to generate useful information about the world, now we can actually understand how this works in a much more concrete neurobiological sense. So imagine a very early brain, lots of these columns generating quite random activity, but all the time receiving sensory information, all this information, patterns of information from the environment, and that is basically activating specific columns and changing the connections between them. And over time, connections that generate useful patterns of activity will be selected for by evolution, and those that don't will be non-selected. Is that the word? Selected against. Thank you. Will be selected against. So this gives us now, you can now ignore this little LSD here. We'll talk about that. That's a little clue. That's the first drug. There it is. So now we can kind of understand what's going on as your brain evolves. The connections change, and the brain generates more and more useful information. So now we can again see this diagram with fresh eyes. We can see exactly what's going on. The information, mutual information between the brain and the environment is increasing because the brain is sculpting itself. It's sculpting the connectivity between the columns. The columns stay the same, but the connectivity between them changes. So the patterns of information generated by them changes. So that means that now when you look out onto the world, you kind of intuitively think the world, you're seeing the world like a video camera. But it's not the case at all. Your brain builds this world and is happy to build this world without any help from sensory information. However, what sensory information does in a modern human brain is it kind of constrains it. So this is a pattern of information from the environment, right? It's not a cortical column, it's just a pattern of information from the environment. And this is the ongoing activity of the brain, of the cortical columns. And if patterns of information from the environment match, this is called sensory matching, match patterns of information in the brain, then they will amplify those patterns of information in the brain. So the world that you experience isn't built from sensory information. All sensory information does is amplify and select on the ongoing activity, the ongoing information generation, selecting specific patterns of information over others. So this is why you live in a very stable, predictable world when you're awake. But it's got nothing to do with your brain working like some sort of video camera and kind of just taking snapshots of the world. A perception, experiencing the world is a very active process. And your brain is building your world all the time. If you want a more kind of visual way of thinking about it, you can think about the connectivity of the brain, giving the brain a certain structure, which in the same way, if you imagine the structure of a wine glass, beautiful tulip wine glass, for example, has a certain structure, has a certain resonance. If you have a different wine glass, it rings slightly differently. If you get a good singer who can sing a pure note, you can get them to sing the right note, and it will resonate. And it's the structure of the wine glasses will require a different note to activate it. So in a way, you can think about the brain kind of tuning in over the course of neuroevolution, tuning into information from the environment and kind of resonating. So for some people, this is an easier way to kind of imagine this. But this is the same thing. It's not entirely scientifically accurate. I don't like to regard the brain as a vibrating structure like this, but some people it helps to visualize it. So your brain is very, very good at building your world. As far as science will admit, this world is the only world your brain knows how to build. And when you are awake, your sensory information is merely constraining, as I said, constraining and modulating the world building. But the world is never built from sensory information. However, briefly, this is how sensory information modulates the world building. So most of the world building kind of goes on in these what I call association or higher areas of the cortex, but again, it's not too important. So this is where the information is generated that builds your world. But the information actually comes, let's just talk about visual information first of all, for simplicity, comes from the front of the brain and is via the retina, of course, and is actually passed by this structure here, the thalamus, to what are called the primary sensory areas, particularly the visual, primary visual cortex. And then from there, that information is passed to these association areas, these higher areas, and basically modulates and constrains the worlds that are being built by this part of the brain. Now, when you descend into sleep and you dream every night, you enter a world that is often indistinguishable from the normal waking world. And in fact, people have done studies looking at dreaming and actually analyzed how long, the proportion of time you spend talking on the telephone versus watching television, for example, in the dream state, compared to when waking, and they're very, very similar. This is called the continuity hypothesis of dreaming, which states that dreaming is continuous with waking. And indeed, dreaming is continuous with waking because the dream world is built using exactly the same information as your waking world. The difference is that when you start dreaming, these primary sensory areas that receive information from the environment normally are shut down. Unfortunately, so are the frontal areas. These areas are responsible for many of your critical functions. So if somebody in the room suddenly disappeared and was replaced by an alligator, we would be pretty shocked by that. We'd think there's something strange going on here, right? Most of you would. But I'm not so sure. But in the dream state, when that happens, it's like, whatever, yeah? You lose that critical function because and you can learn to reactivate it, of course, and this is how lucid dreaming works. You can reactivate your frontal lobes, your frontal cortices, and you can regain that critical function. You go, this is a fucking dream. Yeah, no, that's the kind of thing that goes on, right? That's how it works. But anyway, so when you're dreaming, your brain is building worlds from the same information that it does when you're awake. The only difference is that the sensory information doesn't constrain these worlds. So the worlds can become a little bit stranger. They can shift. They become less stable, less predictable, kind of often more novel. But generally, the waking world is continuous with waking. So we can understand this now, why that's the case. Okay, now. So what happens when you take a psychedelic drug? So let's imagine LSD. This could equally be psilocybin. The neuropharmacology of this is a little bit complex, and I don't want to go into it simply because I don't want to alienate any of my audience, and it would take too much time. But needless to say, so this is the normal waking state. We're familiar with this, and remember that this connectivity constrains and regulates the kind of patterns of information that the brain can adopt. So you live in a very stable and predictable world. Fabulous. However, when LSD enters the brain, what you get is something that I like to call a democratization of cortical columns. So the brain is able to adopt states that it could never adopt in the normal waking state, kind of loosens the brain up. This strict control by this patterns of connectivity is loosened, which is why I've shown this kind of these dotted lines here. And so the brain can essentially start to develop novel patterns of information. And so your world goes from being stable, predictable, reliable, to being unstable, unpredictable, novel. You get strange connections between visual imagery, connections between visual imagery and auditory imagery, and many other strange effects. This can be explained entirely in terms of the way that LSD, which of course itself is a pattern of information, modulates and changes the way that the brain generates information. Nice. Very, very nice. So another way, people often, when they take LSD, they often describe seeing the world as if as a child, like seeing the world anew. And there's kind of an explanation for that, because the evolved human brain is restricted, as I said, and generates information that's very useful and is controlled by these patterns of connectivity. When you take a psychedelic, it's as if the control maintained by sensory information from the environment is removed. Doesn't mean the brain is unable to receive information from the environment. Often it can receive more, but it isn't so tightly controlled and regulating the types of information it can receive. And so all of this information here is, if you like, free information. Here you've got much less of that. This is much more constrained to the useful information that's important for surviving and functioning in the world. So the psychedelic state is a much freer, more novel state, but not necessarily as useful. You know, you wouldn't want to be tripping 24 hours a day, would you? So it doesn't mean, again, doesn't mean the psychedelic state is inferior to the waking state at all. All worlds are built for information. All worlds are equally valid. All worlds are equally real. So don't let anyone ever tell you that these worlds are all, you know, in your head and distortions of reality. People often say this. You read this in old books that psychedelics distort reality. No, 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 no. They change your world. They change your reality. This reality is equally valid. It might not be as immediately useful for surviving in the world. You might not, for example, be able to distinguish a predator from prey, and that could have dire consequences. A bear from a teddy bear, for example. Right? Okay, good. So now we get on to DMT. So I'll talk a little bit about what DMT does, and then we'll have this little break. You can kind of integrate everything I've spoken about. So with DMT, something rather different happens. With other classic psychedelics, what seems to happen is, as I've said, the world goes from being stable and predictable to being unstable, unpredictable, and novel. But it's generally a version of this world. With DMT, something very different happens. You get this 100% reality switch, and the normal world disappears and is replaced by an entirely alien world. It's as if the brain is no longer being constrained by information from this reality, but suddenly becomes constrained by information from another reality, which is why I've shown not a looser set of connectivity, but almost like a different set of connectivities, like a parallel set. So we can think about it like this. With LSD, we kind of stopped here. The brain and the world become less tightly interwoven, less tightly connected. But with DMT, you get a complete severance of the brain information and the world information. But it's as if the brain information is overlapping. It's starting to get mutual information between the brain and world from an alternate reality, the DMT space, this alien reality. Does that make sense? It will make more sense, hopefully, as we go on. So when you smoke DMT, normally what you do is you close your eyes and lie down. There's no point, particularly with a breakthrough dose, of trying to kind of navigate this world. Your brain actually loses the ability to sample information from this reality. So before we had this idea that information from the sensory information is actually matched to ongoing information. So here we can see this pattern of information is matched to this pattern of information already being generated by the brain. But when DMT enters the brain, you get a completely different pattern, a completely different structure, informational structure, if you like. And this pattern of information from the normal waking consensus world no longer matches. So the brain actually loses the ability to sample information from this world. However, the way that the structure, if you like, of the brain changes, it means that information from this alternate reality, this DMT world, suddenly matches. And here we can see this is information, pattern information, not from this world, but from this alternate reality, which is matched to this new ongoing information and amplifies it. So your brain literally starts interacting with another world. Again, for some people, make this a little bit more visual and more clear. Again, before we had this idea that the connectivity of the brain creates a structure which makes the brain generate information in a certain pattern, and this resonates, if you like, with patterns of information from the environment. When you take DMT, this structure changes. The brain starts generating completely novel patterns of information such that there's no longer any possibility for information to be transferred from the external world, the usual external world, to the brain. However, information from an alternative space, after the break I will talk about the nature of this kind of alien reality. But basically it's information that's being received now from this alternate universe, essentially. It's a pretty bold statement for a scientist to make, but anyway, whatever. So now we have a kind of a fairly neat and complete understanding of what's going on here. Is during the normal waking state, your brain is receiving information from consensus reality from the normal world that we're familiar with. This is, forget about 5-HT, don't worry about that. When you smoke DMT or inject DMT, DMT floods the brain, it changes the information generation of the brain, and sensory information from this alien reality can be received. So this alien reality is not distant, it's not far away, it is, as Terence McKenna used to say, one quantum away. Yeah? Raging, yeah, active intelligence, that kind of thing, right? So it's, yeah, so this DMT reality is right there, but we have no access to it, simply because we cannot receive information from it. So now we also have the answer to the question, before I said, what does it mean to be transported to another world? Well, all it requires is that your brain can receive information from that reality. If your brain can receive information from that reality, then you literally enter that reality. So here, this little bad boy, you can see his pattern of information he's generating. This is the alien beast. They've never met. And without DMT, they will indeed never meet. But he consumes some DMT, and we know this changes the structure, changes the patterns of information generation, and suddenly they can finally meet each other. And this is what people experience, of course, meeting, often regarded as very, very, very old friends in the DMT space. Okay, so quick summary, then we'll have a break. So the brain is a complex pattern of information and an information generator. Your world is built, under all circumstances, all the time, from information generated by your brain, but viewed from the subjective perspective. Psychedelic drugs, of course, including DMT, and indeed everything, themselves patterns of information. When a psychedelic drug enters your brain, it interacts with the brain's information and changes it. So it changes your world. Sometimes this can be subtle, with a low dose of psilocybin, for example. Sometimes this can be so profound that your reality literally switches. So, having said that, let's have a break for 10 minutes, and then we'll get to the next part.